The denominator is not factorable, so we can't use like a partial fraction decomposition or another technique that might work for a factored denominator. So to complete the square, we look at the coefficient of x, divide it by 2 and square. When we divide that by 2 and square it, we get 1. I am going to borrow that 1 from the 50, leaving 49. So this trinomial here is now a perfect square, and it will factor. So let's go ahead and do that. So the denominator will now be x minus 1 quantity squared plus 49. And we are in a position where we may recognize that this is looking kind of like the inverse tangent integral. Hopefully you're seeing that. But that integral is a little different. We have dx over 1 plus x squared, or x squared plus 1, doesn't matter how you write it. This is going to give us arctan. So we are targeting this integral. We're going to have to do a little bit of work, though. We've got this x minus 1 to deal with. And you don't have to, but you can use substitution here just to turn that into a u if you want. But notice that if you did let u be x minus 1, the derivative of x minus 1 is just 1, and so you'd have du equals dx. So we don't really need to do that here. Now, there is a formula for the constant not being 1. We could jump to this conclusion and do 1 over a times inverse tangent of x over a plus c. That's another option, which we could do immediately right now. What I like to do is factor out the 49 and go with this original, that basic inverse tangent integral. It's a little easier to remember the basic inverse tangent integrals instead of always trying to remember what you do with the a. It's a little different for inverse sine and inverse secant. And so what I'd like to do is just remember the 3 basic ones and just convert the 49 into a 1 by doing a little bit of algebra. And so let's come over here. I'm going to factor out that 49 from the denominator. And when that 49 comes out, there obviously is no 49 in this term right here. But what we can do is we can always multiply by 1. And so we could multiply this by 49 over 49. And so then there is a 49 that's common that can factor out to the front. And what we'll be left with is x minus 1 squared divided by 49 plus 1. Excuse me. And that sort of puts us very close to that basic form. I'm going to make one more step before we go and do the integration. I'm going to turn this into a single square. So instead of what it looks like above, I want to turn this into a single square, so it looks like that. And now we're ready to go and do our integration. Once again, we've talked about this before, you could use substitution, but you don't need substitution when you have a linear substitution. We can use reverse chain rule. So let's do reverse chain rule. And so remember, with reverse chain rule, we're going to divide by the derivative of that quantity. So we're going to end up with this. And I'm leaving a space right in here because we have to divide by the derivative of this quantity here. Well, you can rewrite that or think of it in different ways. That's essentially 1/7 x minus 1/7. So the derivative of 1/7 x is 1/7. Dividing by 1/7 means multiplying by the reciprocal. So that is going to be what's going to lead us to this final answer. If we cancel out a 7, we'll have 1/7 inverse tangent of x minus 1 divided by 7 plus c. That will be our final answer.